So as previously mentioned, we're going to be presenting about vacuum cycling nucleation technology, or a VCN. So first, I'll explain a little bit about what a VCN actually is. So it's basically a cleaning equipment for industrial cleaning applications. And then a little bit about how it works very briefly. Is it utilizes rapid cyclic phase changes between a liquid state and a gaseous state. And it uses it to dislodge contaminants from really difficult to reach interior spaces of parts, like maybe small holes or ridges. So it's especially good for more complex parts. And so basically looking at this picture over here, the cleaning liquid is able to go into the small space, and then with the use of both heat and pressure changes, the liquid kind of very quickly flips between the two phases of liquid and gas. So when it turns into a vapor, it's able to push up under the contaminant and get it out of the really small space. Um, Yeah, and so because of this, it has an enhanced effectiveness of cleaning chemicals. It shows better efficacy, especially for complex parts than some other cleaning technology. Um, and a VCN can also be used with either aqueous or solvent cleaning chemistries. And I definitely wanted to mention the recyclability capabilities of a VCN machine. Um, so when it's changing between the liquid and gaseous phase, all that vapor and like the foam and bubbles that it creates in the cleaning chamber, they're able to be filtered and kind of skimmed, and they're sent over to a separate chamber where they're converted back into a liquid solution. And then this condensed liquid is filtered again to remove the particulate or whatever of the soil is in there that it was removing. And so then it's able to be reused as many times as it can be until it needs to be replaced. And typically for both solvent and aqueous chemistries, the recovery rate is typically 70% to 95%. But that is dependent on the soil load within the specific process. And additional rinse water is not needed to be added during that part of the process. So while the VCN does the cleaning and is able to recycle the cleaning solution, it also has drying abilities. So it has the cleaning, rinsing, and drying step all within the same chamber. Um, So it's able to use the vacuum technology that it changes pressure with, and it's able to pull any moisture or any residue from the part and also from those small areas or hard to reach areas. And it also works for porous materials. Um, and so this characteristic makes it particularly useful for industries that require their parts to be free of any kind of residue to move on to their next step in the manufacturing process. So things like electroplating, metal finishing, and certain medical devices. And then I have a quick 2-minute video here that basically illustrates the whole process from cleaning to drying. So this is that rinsing phase. You can notice that these vapor bubbles are kind of constantly being cleared out, so you don't need to add in like additional clean water to rinse, basically. And then here's the drying part. All right. Oops. All right. And then I will also dive into some EHS considerations. The process does require the application of heat. So if an aqueous cleaning solution is used, VCNs typically operate between 145 to 175 degrees Fahrenheit. And if it's a solvent chemistry that's being used, the VCN will operate between 70% to 90% of that particular solvent's atmospheric boiling point. And this is the point where it's able to switch from a gaseous to a liquid phase. That's why they want that particular percentage of the boiling point. And VCNs are created by the company specifically for the client. So you can have like whatever requirements you have. So it can be used for flammable solvents as well as non-flammable solvents, um, as long as the boiling point is between 105 to 250 degrees Fahrenheit, um, because this would be a temperature that it could be safely heated to where the solvent would not ignite, but it's still able to hit just before that boiling point, so it can switch between liquid and vapor with the addition of the pressure. And then something to note is that modified alcohol solvents, they cannot be used in VCNs. And this is because they have very high boiling points. So in order for the VCN to reach that 70 to 90% of the boiling point, it would unfortunately be a temperature that could cause that modified alcohol to ignite. So unfortunately, modified alcohols cannot be used in VCNs. And then there were some current concerns about evaporation and air pollution. And so I reached out to someone from a company that we worked with who actually provided us with our VCN that we have in the lab. And I asked about if it meets NESHAP requirements. And he said that he actually wrote the NESHAP requirements. And when he was with his partner, when they were coming up with the idea of a VCN, he specifically mentioned like the reason that they created it was because they saw a need to meet these requirements and specifically for air pollution. So all processes of the VCN do not exhaust to the atmosphere. It's a completely closed loop system, which is referred to as airless by the US EPA. And through testing that they had done, 97% efficient regarding solvent loss. Yeah, so there's really no concerns around air pollution or evaporation. And they meet the requirements of the NESHAP. So, and then I will stop sharing my screen. Um, and I will hand it over to Alex.
Great. Thank you, Amelia. All right. So I am going to pick up where Amelia left off here. And I'm going to be talking about how the VCN, oops, that was the wrong button to hit here. Okay. So how it compares to other cleaning technologies. We have, as we mentioned, we have a VCN unit in-house here. So we've actually had a chance to do some testing regarding that. But we also have some comparative data here in regards to kind of some key variables here. So first of all, the VCN does operate on a 500 to 200 hertz kind of frequency frame. that is something that can be modified depending on the needs of the client. When we spoke to Joe Shooter from Vacuum Processing Systems, who that was the company that developed the one for our in-house machine. He did mention that there was possibility you could add on a designated ultrasonics tank or ultrasonics capability to your VCN system. There's all sorts of kind of different modularity in regards to how these things are constructed. And it is very energy intensive. You know, you're going through very rapid cyclic phase changes at, you know, approaching vacuum. That's just by its nature going to be very energy intensive. And like we mentioned, there is the heating element, which is that's going to kind of work in tandem with your pressure changes to ensure that you are having those phase changes. So it is pretty energy intensive as far as a cleaning process is concerned. And, you know, since this technology is pretty nascent, I would say it's difficult to find like concrete usage data regarding how much a particular machine would be drawing or whatnot. And the case study that I'll be talking about later on, that company didn't actually have individual metering per, you know, device or process in their facility. So they couldn't actually give us any usage data. But as far as you know what we know, and also what we heard from Joe Shooter is that you know it's a very energy intensive process. So and then as far as ultrasonics go, your energy is going straight into the solution. Can vary as far as the frequency. You can have, you know, 40 kilohertz. You can have up to 80 kilohertz. We have one in our laboratory that's 50 kilohertz. It's not as energy intensive. I'd say of the three here, it's probably the most not going to be drawing as much power. And then you have vapor degreasing, which, you know, we heard from Joe. We kind of had some difficulty getting, you know, concrete numbers for this, and I think that this is something that there's like a need for data in regards to energy usage, efficiency, things like that. There is really a need for data collection regarding some of these technologies. And so, you know, as far as vapor degreasing is concerned, we got it on you know, VPS's authority that it's, you know, more energy intensive than even the VCN. And that is because, you know, you're also having that phase change, but they also have, you know, your cooling coils to recondense your solvent or your aqueous mixture to, you know, then reuse that in the vapor degreasing process. But it's since they vary so widely, it is kind of difficult to definitively say what is going to be using more energy. The one we have, the VCN we have in our facility is, I would say, close to bench scale. It's quite small. It's nowhere near kind of one I'll be talking about later in a industrial application. But they're very kind of modular in terms of how they work. But the VCN, like Amelia talked about, it's really good at you know, getting the complex parts cleaned. You're getting the soil out of those blind holes, out of those hard to reach crevices. And depending on what frequency you're working with, there is not going to be a concern that you're going to be affecting the weldability or the kind of the temper or quality of your metal. That's something that we've run into several times in our laboratory if we are, you know, looking at ultrasonics as a method for cleaning different parts. Depending on the application, it's completely a no-go due to how it affects the weldability of the surface. And as far as your actual amount of your cleaner usage, the VCN by its nature, the one that we have is an aqueous model, and the one I'll be talking about a little bit later is a solvent-based model. But our the one in our laboratory, which this is actually a picture of it right here with Amelia and one of our research assistants, it uses just 1% aqueous cleaner concentration. That's the level that we have been testing it at. We've had great results with that based on our laboratory testing. Obviously, it varies depending on, you know, exactly what application you want to use, but more or less you are going to be seeing significantly less usage of your solvent, whatever it may be. Also aided by the fact that it's not open to the atmosphere. You don't have, like mist suppressants, things like that. You're not going to have kind of any worries about recovery externally for this device. It's all self-contained and enclosed. And so now I'm going to just talk about the case study that we piloted with a company here in Massachusetts that works with thermal management products. So they're making things like, cross-plate heat exchangers, different kinds of cooling plates, shell and tube heat exchangers, things of that nature. So really complex parts. In fact, one of the parts they specifically gave us was these copper U tubes from one of their shell and tube, or sorry, plate and frame heat exchangers that was, probably I would say half an inch in diameter, but it was like a 180-degree U bend. And they were having issues with contaminant on the inside of that bend where you can't see it. It's hard to get, something in there to check the cleanliness level of that area. And, depending on your application, it really needs to have a high cleanliness level. And so the VCN was a perfect kind of opportunity to work with those confined spaces and those difficult to clean spaces. And so they actually switched it almost entirely from their vapor degreasing system to a vacuum cycling nucleation unit in 2023. And they've been working on that kind of replacement process for going on a year now. There have been issues. I won't deny that. We keep up with them pretty regularly. But it seems that most of the issues that they have run into have been mechanical related. And I think that is something that comes with the territory of a very new technology that is just kind of coming into its workplace applications. And, they've said over and over again that VPS and Joe have been, very on the ball as far as addressing technical concerns, coming on site and working with the unit itself, recommending process changes or pointing out areas in which there might be issues. But there hasn't been any real concerns as so far as the actual cleanliness of the product. So it's more just ironing out the kinks and really getting this off the ground as far as a commercial application. So, like I was saying, this company is really concerned with cleanliness because if they are, not passing that kind of cleanliness requirements, they have limited opportunity to rework the part, depending on what application it would be in specifically. It may just be, completely thrown out. And so that's something obviously we want to avoid. And manually checking each part is time consuming. So they do really want kind of an assurance that they are getting that high level of cleanliness that they need for their clients. And so insofar as these are the actual notes from this client regarding their specific VCN application here. So one thing right off the bat, it was the same amount of floor space, which I think is a testament to the modularity and the customizability of these VCN units. They are made to order. And, VPS, they do have a patent on this right now. Of course, that as patent law goes, that'll expire in whatever the time frame is, and then it'll be on the general market. And it was much more effective in soil removal than their open top to vapor degreaser. And another thing that we were really happy to hear is that the operators really preferred the VCN as opposed to the vapor degreaser because there was no odor. There was no kind of emission of those potentially harmful solvents into the workplace and then out of the workplace into the local environment. And as far as safety concerns go, it's completely enclosed and it's very well kind of engineered as far as safety interlocks. It's not like you're going to be able to open the pressure chamber when it's depressurized because you've formed a vacuum seal. You can't get that open. And, there's very limited, because of the nature of the solvent, how diluted it is, they weren't getting a lot of exposure when they were opening that chamber to retrieve the parts out of it. And so, the vapor degreaser, the open top one, had significant safety concerns and constraints and procedures that they had to apply within the workplace to ensure that they weren't getting exposed, their coworkers weren't getting exposed, things like that. And something not mentioned here, but also it did reduce their actual usage of solvents over the course of their year that they've been implementing this. They've been using significantly less than they would have been using with the open top to vapor degreaser. And this is also a table that was actually provided to us by one of the engineers on site. And as far as kind of looking at upsides and downsides here, it is a pretty significant upfront cost. This is not a cheap system, and I think that is definitely because this company was very kind of, I would say, coming into this with good faith and willing to essentially pilot what was an industrial scale prototype for this device. And there was so initial upfront cost, but you had not as much training as something like an open top vapor degreaser, maybe not as simple to operate as something like an ultrasonics where you're just hitting a button and it goes. But as we've talked about, because of the nature of the system being enclosed and the efficiency and recycling capability, it's going to be the most environmentally friendly. And the process development here, so that's referring to kind of how to integrate this into whatever product line they're looking at here. So that was something they had a little bit of challenge with, because you're working with a pressure chamber. There's not as much kind of potential for automation. Also, because, like I mentioned, the technology is new. So there weren't, things on the market that could interface well with these devices. So it was a lot of manually putting parts in, taking them out, things like that. But like I said, I think that's not so much a downside of the technology inherently, more that it is just an emerging product. And in terms of operating costs, like we talked about, it is a power hungry device. It requires a lot of energy to run. So you may be looking at more insofar as your electricity bill. That could balance out depending on whether you're using a solvent or aqueous version. That could balance out your chemical usage. You might be using less over the span of your year or things like that. And that is all I have for you today. So I just wanted to give a shout out to Joe Shooter of Vacuum Processing Systems. He has been an absolute angel so far as answering all of our questions. And, really, I would say being quite frank in the limitations and, maybe downsides of his technology, but also really, I think he has made something that is absolutely incredible. Its potential is, I don't think we've even come close to it as far as what kind of applications this can be used for. I know that they're currently working with NASA on developing a very large scale one for cleaning their SRBs. It's definitely something that people are interested in. And, I think our presence here today attests to that. But any questions? Is there anything in particular people wanted me to go back and look at again? Or you can drop it in the chat. You can just unmute yourself, whatever works best for you.
Yeah. Feel free to ask questions. We got plenty of time. And while we're waiting on those, what about applications in the medical technology industry where there may be some concerns about cleanliness or residue? Have you worked with any clients who may be subject to FDA requirements on using a certain cleaning technology, or are concerned about residues on a part that may be potentially put into a person's body?
It's a great question. And, I actually, Alicia is the one, our expert on disinfection, sanitization, and cleaning in that regard. I do know that the case study I mentioned, they do make medical devices. I'm unsure specifically of which ones. I can't really talk about it. There's some confidentiality there, but um, I would assume that depending on the application and depending on what cleaner you're using, you can, achieve that level of cleanliness that's necessary. Or perhaps, if we're talking about something, like in the demo video, there's a hip replacement. You may have a sanitization step that takes place after your cleaning step, which would be something that'll be outside the VCN, might go into, I don't know, a BSc of some kind. But as far as we can tell, there is, I'm not totally very familiar insofar as sanitization applications with something like a VCN. I imagine you could probably engineer one to do that since you already have, a significant heating element. You might, somewhat like an autoclave or something like that. But honestly, that is something that I can ask Joe Schutert, and I can get back to you with a better answer on that.
Okay, thank you. I don't want to hog up your time because I'm certain that, some of the other participants on this oh, here, Donovan, go ahead.
Sure. Thanks, Mark. Definitely a great presentation. Do you find as you continue cleaning it that the items that you are removing will change your vapor phase pressure requirements? Because looking at it from a physical chemistry standpoint, as you change the vacuum, certain things can boil a lot easier, but as you add in different impurities, you sort of change your phase point.
Yeah, excellent question. And that's definitely something that, insofar as our lab scale model, we do actually, we'll run it, I would say, 3 times with a set of parts and contaminants. And it's on an automated system, so it automatically heats and pressurizes to certain set points. We haven't seen any significant kind of issues regarding that, but I do know that in the industrial scale application, they do actually run the solvent through a oh, Amelia, you're going to have to give me the word for this. I'm totally forgetting what it's called. They do have a filter system in there that pulls out some of that contaminant before it goes back into your vacuum chamber.
It's called the knockout pot.
Thank you. Thank
Yeah.
you. The knockout pots. Yes. So, in our like lab scale testing, we haven't seen a lot of that. That being said, I would say the soils that we've been using have mostly been lubricants, oils, coolants, things like that.
Mhm.
But I think that is something that is solved with a built-in filter for something like that.
Okay, for those that are in liquid form as you remove it, as you're talking about with like oils and lubricants, do you also consider potential fractional distillation separation to help clean your solvent?
Alex,
Oh, please, Alicia, go ahead.
I was going to say, just Donovan, I think also from the aspect of what we've tested so far. So this is the type of information we're really interested in learning of what people care about understanding. It's something we haven't explored yet. Where we have the equipment, we've only really kind of been taking some of the contaminants that we've been commonly seeing within the industry and just testing, does it work or doesn't it work? And that's really where we're at internally. I think the work that we're doing right now with the company that we were talking about, they've been the most informative into the real world applications of it, besides engaging with the vendor and RIT, which is another school that has the solvent version of that equipment, is also doing their own research. So we're trying to share information, but for what you're asking, we don't have that info, but we could definitely make note of that to start putting that as part of our research priorities, if that's something of interest to you.
All right, very cool, and definitely a great system.
Thank you, Donovan. I appreciate it. iPhone 2. I don't know what your name is, but please.
Oh, sorry. Yeah, sorry for that. So I'm attending the meeting in the phone, so that's what is showing the iPhone. Sorry for that. So my name is
Oh, no worries.
Rajavel. So I'm basically working in K-State PPI. So I have seen your report. It's very detailed. It's very interesting, and like it's very more informative for industrial scale. I'm just wondering, like the ultrasonic processing. So the during the ultrasonic processing, it not only going to reduce the remove the residue or like grease or any material, it also creates some porosity on the surface of metals, right? So do you have any like suggestions or like something like you are planned to use it? Because most of your report is basically on like the solvent exchange or like suitable solvent thing, but like when we are providing ultrasonic, in my understanding is right, in the material surface property there will be a porous formation, and most of the industries they are using like some surface treatment to adhere the more coating to have more adherence to the surface. So is that impact the ultrasonic cleaning can impact that kind of porosity that can again increase or decrease the lifetime of the paint coating? Do you have any idea or comment on that?
So that's an excellent question. And, that's something that we have gotten a lot as far as, like I mentioned, clients expressing concern over, damaging their parts or affecting the kind of, like you said, the lifetime of your surface coating with our ultrasonics units. And, I should make it clear, our VCN does not have an ultrasonics unit attached to it. That is something that, the case study I talked about, I believe they did have one, albeit it was not like in the vacuum chamber. It was a separate component of this VCN. So there's not going to be that kind of surface damage on within a VCN unit. You're not going to get that pitting or that porosity like you would with an ultrasonics tank. Um, so as far as kind of concerns with coatings, I think that's something I'd be very interested to know about. We haven't conducted any specific research on something like that, but now that you mention it, I could already think of a couple different applications and tests we could do on the kind of stability of different coatings. Was there a specific one you were wondering about?
Not specific one, because like I think like we have like a project with the TURI, like our PPI have like project with the TURI, then I have seen the report. So I'm not sure about the specific material. I need to check with my colleagues because I'm new to this kind of project. So maybe I will check with my colleagues then, and then our director, then I will reach out to you if there is any feasibility of doing the things we can work on that. Yeah.
Absolutely. Please do. I'd be
Yeah.
very interested to learn about that. And, I think that what we're trying to do at TURI is really build out that kind of base of research and data on, things like this, of ways in which it might be incompatible with different substrates or different coatings, depending on the application. That's something we really want to build out and get a lot of testing data for. So, we can be a little more kind of have more robust recommendations insofar as when we talk about this technology.
Yeah, sure. Thank you.
Of course. Rajavel, please.
Yeah, this is me. So like, I don't know. There will be some confusion. So
Oh, I see. No worries, no worries. All right. Well, if there's no other questions, I will. Oh,
Alex,
please. Yes.
question. Cycle times, are they standardized, or is there some type of evaluation as far as level of cleanliness to ascertain the, duration of a cycle?
I can answer this one.
So please go ahead, Amelia.
Okay. So a VCN cycle is typically pretty short compared to other technologies. I know the one we have in the lab is set for a 1 minute cycle, and it can range from 1 minute to maybe 5 minutes. So it's something you would have to kind of figure out with some pilot testing on site for the specific application, but it would be very short compared to if you were using a different technology.
And I presume that would vary depending on the degree of soil contamination.
Exactly, yeah.
Okay.
But it's designed to work very fast because it's so energy intensive and there's the application of heat. Those two things are able to kind of take the time requirement down, and that's why it's so short.
I noticed the company that you're doing the testing for. They do some plating. So did you follow up with? I presume they do the plating after the VCN technology. So was there any evaluation as to the quality of the plate after the application of VCN?
So as far as we did actually discuss with this client developing kind of evaluation framework for cleanliness testing, because this was something that they coming into this were not as familiar with, and they didn't actually have a framework for evaluating cleanliness going into this project. So I know that we actually had them come on site with us, and they were able to look at some of our evaluation methods. So we do things. We have a contact angle test. So that's for your kind of what's the word I'm looking for? Like hydrophobicity of your substrate. So you're looking at the angle that a water droplet is forming on your surface, and using that, you can determine if you have like a waterproof coating or something like that, or a hydrophobic coating, or oleophobic coating, depending on your application. You can determine. I'm forgetting the unit off the top of my head, but you can determine how well that kind of rejects that substance. So that's one that we use. We have different kinds of wipe tests in terms of checking for remaining residue or things like that. We have something called a white glove test, which is about as simple as it sounds. That's particularly useful for metals and things like that. But specifically with the client, I think that you are correct. The VCN was utilized prior to their electroplating. And I honestly don't know off the top of my head what evaluation criteria they adopted for that. Amelia or Alicia, maybe if you guys remember that. I don't know if I was there for that specific meeting.
Are you talking about for in-house for the adoption of the newest cleaner, or the one that they were previously using the VCN for?
I would assume the newest one. I was just wondering about the cleanliness criteria they were using.
So they're not using a VCN for the newest cleaner. It's
Mhm.
so the one that they were using it for, how they determined cleanliness, they basically did a side-by-side comparison because they had metrics in place for their TC open top vapor degreaser at that time period. So they basically just using metals that they had tested and already had validation of whether it was acceptable or not, looking at surface tension in-house. They compared to the VCN just to make sure that they were getting a similar outcome for the plating process itself. I will also note too, like when they were first adopting it, now it's gotten much better, where Alex was talking about how they like using it. One thing, and I think it's important for people to know, because there are only certain vendors that actually manufacture this particular piece of equipment as well. There's a lot of modifications that need to be made. So when they adopted it, they actually had to have a lot of their internal engineers tweaking it to make it more user friendly, because just like ours, it's very much as if it was made in a lab, and that's why they kind of contract out to these different vendors to manufacture larger scale applications of this type of equipment and technology. But it did take some time for them to kind of find out what would work best. So I think when it comes to helping companies with finding safer alternatives, it's really important to make sure and check, do they actually have engineers on site that know how to tweak, manufacture, and modify certain types of equipment, so that way they're not having to hire someone and outsource someone to come in and make those modifications for them. Because as much as they got assistance from Joe and others, it was also a lot of work on their time to make sure that it fit their needs. So bandwidth is huge, and I think also time as well.
So I assume, I don't recall if this company does aerospace work as well. But I presume, you've tested this with a number of aerospace companies, or it's been evaluated by an aerospace company.
Yes. So I don't know the specific details. Though I mentioned that they were working with NASA. We have actually for a previous project with KSPPI, we did try this as an application. I don't think we ended up adopting it, but I know that the aerospace criteria are very stringent. They're very specific, especially if you're working with any kind of defense application. But as far as I know, NASA had conducted their own kind of evaluation on the feasibility of it for their sought after application.
So I don't see anyone else waiting to ask questions. I am very grateful to Alicia for helping to kind of orchestrate this presentation. I'm very grateful to Alex and Amelia. I wish you well in your educational endeavors. You seem to be very bright and intelligent, and I wish you a very prospective future. Again, I am very impressed with your presentation and very grateful of your willingness to prepare it and deliver it today. Thank you very much.
Yeah, thank you for inviting us
Thank you.
to do this. Yeah, it's awesome.
And if you
Yeah,
have
thank
any
you, Mark.
suggestions too for